Here we've got another question on Euclidean geometry. We are told again here in the diagram, O is the center. So I've got a center. And again, remember, once I have a center, I must think again of what? The diameter. Okay, because I know diameter subtends 90, and I must think also of the radii. Okay, and guess what? There they tell me diameter LR, okay, subtends LKR at the circumference to the circle. So as a matter of fact, I can put in information here that this thing is actually 90 degrees because diameter subtends 90. In fact, the examiner here was very friendly to say, I'm giving you information here, go for it. N is another point on the circumference, and chords LN and KN are drawn. What do we know about chords? From chords, we can get angles in the same segment, okay? Or we know that equal chords, okay, here we are not told if the chord is equal, so we can just say a same chord can subtend, does subtend actually equal angles, okay? So that's what we know. As a matter of fact, here is the chord. Where is called Ln, here it is, and there's called what? Kn, where is Kn? Here. So let's see, this chord here and that chord actually does not really give us much information, because if you think about it, this chord literally subtends one angle, and it is this angle here. So this chord here literally subtends that angle, okay? Well, maybe you may say another angle that it subtends could be that one, right? That's fine, okay? Then this chord here, what is another chord that we are directed to? Kn. Well, sure, you can say it subtends that angle here, okay? Maybe let me just take a different color as well. Maybe you can say that one subtends this one here. So yeah, maybe we can go with that, look at that, and then, but well, they are not equal. So what are we gonna really do about this? So for me, that's not enough, really best information that I would put into use, okay? So what rather I would put into use the fact that actually this chord at this angle here is subtended by that chord, and actually this angle here is also subtended by the same chord. So angle N must be equal to angle R. So for me, that really does it, okay? So calculate given reasons the sines of LKR. Guess what? As you were filling in the information, you already knew the size of LKR. So LKR is actually 90 degrees. Why? Because diameter subtends 90, or actually you can say angle in a semicircle. That's subtends 90, or you can say angle in a semicircle, okay? I'm just not gonna write in full because you can hear me and I'm sure you are following clearly. What about R? Angle R, so you look at triangle LKR, okay? We can't say, we at this point, we can't really use the fact that R is equals to N because we don't know the value of N, okay? But we know that this thing is 90. So, you know, in a right angle triangle, let me just take your minds back. If I've got this as 90 and I've got this as theta, okay, then that angle is just 90 minus theta. And how are we getting that? Sum of angles in a triangle. So it is clear now that R here is 90 minus 58, okay? And I think that's something like a 32 there. And yeah, then we are done, okay? So we know that this thing is 32 degrees. So this here is 32 degrees. And then guess what? As you're filling in information again, you know that N equals to R, and this is also 32. So here, what are you saying? Angles in a triangle are supplementary, okay? Here, N equals to R, which equals to 3 angles in the same segment. Same segment. Okay, that's it. Easy as ABC. Okay, guys. So please just try and develop this thing of extracting information from the question, putting it in the diagram where possible, and also writing the possible conclusions that you can get to. Cheers.